Hello everyone, welcome to my channel. Today we are going to look at the three-sum problem from Leetcode. The description for the problem is as follows. Given the integer array numbers, we will want to return all the triplets so that their summation will be equal to 0. And the solution set must not contain duplicate triplets. So here are some of the examples. We will be given integer array numbers, and from that we will want to find out the combination of three elements such that their sum will be equal to 0. If the given array does not contain any element, then we will want to output the empty solution also. So how do we solve this problem? Before we dive in and solve the three-sum problem, let us assume that we only need to solve two-sum problem. In this problem, we will have the given number of array m. The target will be the 9. In our case, we will want the target to be 0. But let's assume we want the target to be 9. And first, we will want to solve the given array so that they will be in the minimum to maximum order. And we could use the greedy search algorithm to find every possible combination from the array m, compare with the target, and see if they are equal. But that will be inefficient. So we could use a two-pointer for this problem, in which we assign the minimum and maximum value to the particular pointer, and we sum these values and get a sum and compare with our target. And if the sum is greater than our target, that means we want to move this pointer a little bit to the left, because the left element have lesser value than the right element. So we continue the process until we find the sum that is exactly equal to the target. So the three-sum problem can also be the extension of the two-sum problem. So let me show you the code. Okay, now we are in the Leetcode, and this is a three-sum problem. We will be given a number. We will be given an array m. We want to find the results. First, let me just find the length of the numbers, and we could initialize the result string, result list, and we will output the result, right? And for that, we could just iterate for I in range of n-1 and -2. That will be 2 because the first iteration we only need to iterate to the left before the last two elements. And we have assigned the left and right pointer to this, and left pointer will be i+1 and right pointer will be n-1. That means the left mode and the right mode. And why the left is less than right, then we will have to find the summation of the array. That will be numbers of plus number of left plus number of right. If the summation is greater than 0, that means we will have to reduce the right, move the right pointer to the one before and continue. As if summation is less than 0, that means we will have to add 1 to the leftmost pointer. Continue will not be needed. And as that means the summation is equal to 0, we will want to append the correct numbers to the results. So yeah, that will be it. And we would like to avoid the duplicate triplet. So if the left is greater than i+1 and number of left equal to numbers of left -1, that means the left pointer is repeated, right? So we will want to add 1 to the leftmost pointer, and if the same apply to the right -1 and -1, and number of right equal to numbers of r plus 1. That means we want to negative 1 and continues. Yep, that is it. Or also, we even if it's the same time, we will have to left plus or equal to 1, right negative or equal, right negative or equal to 1. Okay, and for that also we for the I number, we will also want to create the avoid the duplicate. So numbers of I equal to numbers of I negative 1. Then we will have to continue not finding the element because this element is already being inspect for one time, so we don't want to inspect another time. So yeah, that will be it. And let's check if our code is correct. Oh, why? Oh, it is very important that we solve the array first, because if it is not sorted, then nothing will be true. Okay, so run the code and submit. Let's see about this. Okay, so we solved the problem.